So we have a lot going on in this video today. We are going to address 3 learning targets. So as you're recovering your learning targets, you may need to be recovering all 3. You may need to be doing 2 or maybe just 1, but these all go together, so I'm doing them together. This is the same exact questions you had on your test. So as you work through this, you'll see what your test questions looked like, why you got them wrong, how they are correct, and then you'll practice that and retest. Okay. First one we've got here is I can interpret the slope in the y-intercept. Next one is I can determine the rate of change in the initial value. I have some vocabulary there that means the same thing. I usually use green for y-intercept and initial value. Those mean the same thing. Okay, so we need to be comfortable when we see those that those are the same thing. Slope and rate of change mean the same thing. And then our last one is I can write an equation from a table, graph, and in context. All right? We can't interpret anything without determining it first. We have to identify it and determine what that rate of change in initial value is before we can put it back into context, which is your interpreting. All right, so here we go. Mr. Elliott needs to drain his above-ground pool before the winter. The graph below shows the relationship between the number of gallons of water remaining in the pool and the number of hours the pool drains. So here's your relationship. That's your relationship right here. It's linear because it's straight and it's decreasing, so it's going to have a negative rate of change. So this says determine the rate of change in the initial value for the relationship and explain what they mean in this situation. So rate of change and the initial value. We're going to start with initial value. On a graph, the initial value is where the graph line itself is coming through the y-axis. So it's the point where the graph line is intercepting the y-axis, the initial value, how much water was there at time 0 or 0 hours. That coordinate pair there I should see is 0, standing for 0 hours. I've gone over 0, and I go up 10,080. Okay, I go over 0, and I'm up 10,080 gallons. So let's put some words with this since we're going to have to interpret that. So when it says I can determine, I should see on your paper that it says initial value. And I might see something that says 0, 10,080. Okay, putting that into context, so we're interpreting that point right there. And we're going to say 0, that's hours, and 10,080 is gallons. So what I should see written there is the pool was full of 10,080 gallons of water before I started to drain it, right? The time hasn't started. So I'm going to write here the pool started with 10,080 gallons of water. So when people are swimming it, that's how much water is in there. That is all green. That is all the initial value. All of that. Okay. Looking at rate of change. Rate of change on a graph, there's a couple different ways to do this. One, we can draw slope triangles. So from 2 good points, this is a good point, that's a good point. We could find the change in the y over the change in the x using the graph. Okay, and the change in the y is the vertical change, and in this case we are changing vertically going down, so my arrow is down. And we changed by starting at 7,200 and we end up at 5,760. So if I do that subtraction, 7,200 minus that point where I ended up here, okay, that's 1,440, and it went down. It decreased by 1,440 gallons. So I'm going to put G. For every, okay, their change in our x is our horizontal change. So I'm here and I'm trying to get to here. Started at 4, went to 6, so it changed by 2 hours. We decrease 1,440 gallons of water for every 2 hours. 2 hours. All right, that's the rate of change. We can simplify that to a unit rate and turn that into negative 720, and because I'm running out of room, I'm not going to write it, gallons, right? I'm dropping 720 gallons for every 1 hour. We do that by division, numerator divided by denominator. So over here, we're going to write rate of change. And I'm going to write the rate of change is negative 720 gallons over 1 hour. All right, because that's what I've got here. And then I just determined it. Now I've got to interpret it and actually put that into a sentence. The pool drains 720 gallons every hour. Right, and that entire piece there is rate of change. I'm going to make that blue. That's rate of change. All of that's the rate of change. Okay, that rate of change is all right there. This is all part of finding that rate of change there. Now before moving on to the next part, I'm going to show you also how to take your graph and turn it into a table so you can then find your rate of change through a table. So say for example I couldn't remember how to do the slope triangle, then I'm going to just model this and put hours and gallons as a table, hours and gallons, and I'm going to find two good points. So in this case I'm going to use this point. That point is 4 hours and 7,200 gallons. I'm also going to use this good point here, and that is 6 hours and 5,760 gallons. Okay, use the same exact points. Now when I do the method of change of y over change of x on the table, I'm going to see that this is dropping by 1440 and this is increasing by 2. And these two values are going to be the same exact things that show up right here, which is then going to be simplified to this, which is the same piece. Okay, so this is an alternative way of this. Okay, you do what works for you there. All right, so far right now we have done 2C, we've done 2D, now we're going to do 2E. I can write the equation of a linear function from tables, graphs, and in context. Okay, so write the equation that models the water level of pool at any given time. That's what we're about to do right here. Writing the equation. So I'm going to say this is y, this is x. I'm going to say y equals rate of change, so I just abbreviated that, rate of change times x plus your y-intercept. Okay, that's going to work every single time. So there's your y-intercept, here's your rate of change, and so you end up with y equals a rate of change of negative 720 because we found that here. So I'm just taking my parts. We said we're going to take that rate of change and multiply it by x, and then we're going to add in our initial value. Because it's positive, it's going to be addition. If it was negative value, you would subtract it. Y equals negative 720x plus 10,080. Okay. Did we in fact represent our situation here as an equation? And the answer is yes. I'm going to do the second part, questions 3 and 4, on a separate video just so this one doesn't get too long.